atoms are so small and light that ordinary units, such as kilogram or gram, are unsuitable. This is exactly how we estimate the atomic mass of an atom, since we cannot directly calculate the mass of an atom. For example, one carbon atom has a mass of 1.992 times 10 power minus 23 gram, so an atom is tiny and light. Scientists found a simpler way to calculate the mass of an atom. We usually calculate it with respect to the mass of a carbon atom. We take carbon-12 as our standard. In the past, scientists had previously attempted to use hydrogen and later oxygen-16 as a reference, but as heavier elements and new isotopes were discovered, it resulted in physicists and chemists disagreeing on masses. In 1961, scientists eventually agreed to choose a carbon-12 isotope, which has 6 protons and 6 neutrons, to be the standard atom. Then they fixed it as exactly 12.000 units, called atomic mass unit, AMU. Masses of all other atoms are compared with this reference standard, to give their relative masses. The relative mass of proton and neutron are equal to 1. Carbon-12's atomic mass could be measured particularly accurately, compared to the other elements on the periodic table. On the C12 is equal to the 12.00 scale, since the relative masses of a proton and a neutron are both very close to 1. The relative mass of an electron is nearly 0, thus the relative isotopic mass of an isotope is roughly equal to its mass number. Relative isotopic mass, it is a unit of measurement that is based on a comparison to something, or in relation to something else. That something else is a neutral unbound carbon-12 atom. According to the carbon-12 scale, a magnesium atom has the same mass as 2 carbon-12 atoms. Its relative mass is, thus 12 times 2, is equal to 24. Calculating relative atomic mass. Method 1. Different isotopes have different masses. Let's take a look at chlorine as an example. Now chlorine has 2 stable isotopes, chlorine 35, which has an abundance of 75.4%, and chlorine 37, which has an abundance of 24.6%, and we say abundance, all we mean is how common or rare that isotope is. So, if you were to pick up a handful of chlorine, then on average 75.4% of the atoms in your hand would be the chlorine 35 isotope, and the other 24.6% would be the chlorine 37 former. And one of the things that you need to be able to do, calculates the average mass of all the isotopes that make up a particular element, which we call a relative atomic mass. Now in an exam you might get a question, calculate the relative atomic mass of chlorine to 1 decimal place. The equation for relative atomic mass is a sum of isotope abundance times isotope mass, divided by the sum of the abundances of all the isotopes. So, the first thing we do is multiply each isotope's abundance by its mass. For the chlorine 35 isotope, this would be 75.4, which is its abundance, times 35, which is its mass. And chlorine 37, it would be 24.6 times 37, then we sum these two figures together, which means we add them together. Lastly, we divide this by the sum of the abundances of all the isotopes, which in this case would be 75.4 plus 24.6, 75.4 times 35 gives us 2639, while 24.6 times 37 gives us 910.2. And then we add these together to get 3549.2. On the bottom 75.4 plus 24.6 gives us 100, which makes sense because there are only 2 isotopes, so together they should add up to 100%, so that they represent all of the chlorine atoms. So, we divide 3549.2 by 100, and our answer is 35.492. but as the question asks for 1 decimal place, we give the answer as 35.5, so we could say that the average mass of a chlorine atom is 35.5. Method 2. Note: the relative atomic mass of 35.5 is not the relative mass of any one chlorine atom, but the weighted average of all the chlorine atoms present.